So let's do the integral of ln of the square root of x plus 1. We can start by applying integration by parts and let u equal ln of the square root of x plus 1 and dv equal dx. If we differentiate u, we get du equals 1 over square root of x plus 1 from differentiating ln of the square root of x plus 1, and then by the chain rule, we also need to multiply the derivative of square root of x plus 1, which is just 1 over 2 times the square root of x. And since dv equals dx, that means v just equals x. And we can simplify the du expression a little and just say that this equals 1 over 2 square root of x times parentheses square root of x plus 1. Actually, let me just delete that first expression for du. Okay, that's better. So du equals 1 over 2 square root of x times parentheses square root of x plus 1. Actually, you know what? I need to move this to the side, and I also forgot to add the dx at the end. So actually, du equals 1 over 2 square root of x times parentheses square root of x plus 1 dx. Anyways, if we apply the integration by parts formula, the integral is equal to uv, which is x times ln of the square root of x plus 1 minus the integral of v du, which would be minus the integral of x over 2 square root of x times parentheses square root of x plus 1 dx. We can simplify the integrand by dividing both the numerator and denominator by the square root of x. So the integrand just becomes the square root of x over 2 times square root of x plus 1. So we can now do a U-substitution to deal with this expression. We can let u equal square root of x plus 1, and I let u equal square root of x plus 1 instead of square root of x, just so that the denominator becomes a single u expression. So if we do that, then du equals 1 over 2 square root of x dx, and if we multiply both sides of this equation by 2 square root of x, we end up with dx equals 2 square root of x du. So we would like to rewrite 2 square root of x du in terms of u only. So let's look at the relation u equals square root of x plus 1. If we subtract 1 on both sides, we end up with square root of x equals u minus 1, so we now have an expression for the square root of x in terms of u. So 2 square root of x du becomes 2 times u minus 1 du. So dx equals 2 times u minus 1 du. So if we substitute this into the integral, the first part of the expression, x ln of the square root of x plus 1 stays the same, and then we have to subtract the integral of u minus 1 over 2u, since the square root of x equals u minus 1, and we also let u equal square root of x plus 1. So square root of x over 2 times square root of x plus 1 is u minus 1 over 2u, and since dx equals 2 times u minus 1 du, we also have to multiply 2 times parentheses u minus 1 du. The 2 and the 2 in the denominator cancels out, so once we simplify the integrand, this just becomes minus the integral of u minus 1 all squared divided by u du. We can expand the u minus 1 all squared in the numerator of the integrand, and after just copying the first part of the expression, we end up with minus the integral of u squared minus 2u plus 1 all over u du. And of course, we can simplify this further by splitting this fraction. So u squared over u is just equal to u, 2u over u is just equal to 2, and 1 divided by u is 1 over u. So we can actually rewrite the integrand as u minus 2 plus 1 over u. We can actually just integrate each term separately now. So this is x ln of the square root of x plus 1 minus, and then we need to put a big parentheses at the front because there's a negative sign in front of the integral. And the integral of u is u squared over 2, the integral of negative 2 is negative 2u, and the integral of 1 over u is ln of the absolute value of u. And of course, we need to add the constant of integration c. We originally substituted u equals square root of x plus 1, so the first part of the expression stays the same, and then this is followed by minus parentheses square root of x plus 1 all squared all over 2 minus 2 times square root of x plus 1 plus ln of the absolute value of the square root of x plus 1 plus c. Alright, so let's clean up this expression a little. The first part of the expression stays the same as always. And let's see what happens to the expression inside the parentheses. So we have minus parentheses, and then square root of x plus 1 all squared. If we expand that, just becomes x plus 2 square root of x plus 1, and the 2 in the denominator stays the same. If we expand negative 2 times parentheses square root of x plus 1, we end up with minus 2 square root of x minus 2, and ln of the absolute value of the square root of x plus 1 can actually be rewritten as ln of the square root of x plus 1 without the absolute value, just because square root of x plus 1 is always positive anyways, so we don't need the absolute value, and the plus c stays the same. If we simplify the expression inside the parentheses further, it becomes like this, where x divided by 2 is x over 2, 2 square root of x divided by 2 is the square root of x, and 1 divided by 2 is 1 over 2, so that's the first term taken care of. Everything else stays the same, and if we combine like terms, this just becomes x ln of the square root of x plus 1 minus parentheses x over 2 minus the square root of x minus 3 over 2 plus ln of square root of x plus 1 plus c. And now we just need to get rid of the parentheses, and the final answer is just x ln of square root of x plus 1 minus x over 2 plus the square root of x minus ln of the square root of x plus 1 plus c. And I omitted the constant term of 3 over 2 just because that's covered by the constant of integration c. So technically the c in previous expressions is not the same as the c in the final answer, but I'm not going to worry about that, and let's just say it's plus c. So the final answer is just x ln of the square root of x plus 1 minus x over 2 plus the square root of x minus ln of the square root of x plus 1 plus c. And this is another big expression.